Hello. This demo illustrates the ideas detailed in my blog post regarding the CareTaker collection. The link to that post will be in the video description below. This drawing illustrates at a high level the sequence of steps that occur in a network operations team that embraces Git-centric operations. At a high level, we have two Git repositories. One repository stores the configuration as code, so that might be your data structures like your VLAN configuration, your BGP configuration, so on and so forth, that have been recorded as data structures. You have another repository that contains the last known good configuration that was made on all these network devices here. So a typical operation might be where a network operator modifies the infrastructure as code content, submits a pull request to the IAC repository, and after all the testing and approvals, it gets merged into the master branch, and then that triggers a webhook on Ansible Tower that goes in, finally deploys the configuration to your network. Right? So that's a typical workflow. Now that the configurations have been modified on these network elements, um, this new configuration is then uploaded and saved into a different repository. I'm calling it the last known good configuration, right? So for our demo, we have those two repositories here. So I have repository one where I have my data structure, right? I'm defining my BGP as a data model here. And then over here, I'm having a second repository that contains the running config of the devices. From a topology standpoint, I'm simply running just two EOS devices in a private AS, and they are configured for iBGP. So from a steady state operation standpoint, what's going to happen, right? A network engineer is going to come into this repository and is going to request some changes to this data model. So specifically for our demo purposes, we might just be adding or removing prefixes that need to be advertised into the iBGP configuration. And when those changes are made, the repository will, if there's any testing, if there's any approvals process required, all those will take place, and finally configuration gets deployed to our routers here, right? So here I have routers 2 and router 4, and as you can see, there are currently two networks that have been configured for the BGP on these devices. So let's say we want to add a new network to router 2, right? So I would come in here, and then I would submit a pull request, right? So I'm making an infrastructure as code change, and I'm simply doing it over here in the GitHub UI to illustrate it quickly rather than use a clone the repository and make the changes and push it and all the good stuff. So let's say I'm going to add a new prefix. So this time I want to add 10.25.27.0 mask plan 24. Okay. So I'm not going to do anything here, submit a change, right? So I'm committing this, right? So when I commit this change, because of how I have a webhook defined inside Ansible Tower, I'm going to look at my last job. So you can see that the webhook kicked off this particular workflow, the CareTaker workflow, right? And over here, right now, it's trying to deploy the changes. So it will only deploy successfully if the running config is in sync with the configuration in the last known good config repository. And as we saw in, when we quickly looked through it, we saw that, they were pretty much in sync. So this should succeed, and it should not take any of these failure branches, and therefore it should simply deploy this new configuration, or it should commit this new configuration to the endpoints, and then back up that last known good config into the last known good config Git repository. So as you can see, this particular job was successful, and therefore it's going to simply back up the configuration changes. So once this is complete, we should be able to see that network, the 10, 25, 27/24 network appear in our last known good config. So let's just wait for this backup job to complete. Okay, it's done. So now if you go in here and if you refresh the config for router 2, all right, we see that the new network has been added to this router. We can also confirm this on the device itself by checking that the new network has been added. So this is steady state operations. Now let's say that, for some reason, um, you've had to come in here and make some configuration changes. So let's say any kind of configuration changes, right, that might have caused this device or the running config to be out of sync with the stored config. So let's do this. Let's add a new interface. Oh, no 0. Okay. Okay, so I made a change. So let's say this is, during operations, and this change had something to do, you had a bug or there was an outage, you had to make some certain change on the device, so you were all hands on deck, somebody manually made a change. That could be one reason. Another reason could be, this an engineer who's new to your environment, does not know the Git operations procedures, and just decided that, hey, I'll just go. I know networking really well. I'm just going to go into these devices and going to make the changes, and then I'll figure out how to make the changes or backtrack the changes with the Git team or whatever, right? So at this point, you have a situation where your running config is out of sync with your last known good config. So if an engineer was to come in here into our steady state operations, right? And they were to make a change. So let's say for some reason I'm going to either remove this network or add another network, and this change might or might not conflict with that out of band change that has been made on that device that can potentially cause an outage, right? So if I commit a change through this process now without some sort of checking process, this is going to overwrite all the configurations on the network endpoint, or it might cause some conflict, or it might cause some outage, right? So ideally, you want to make sure that your last known running config is in absolute sync with your last known good config, and your running config are in absolute sync. So let's try and demo that situation here, right? So right now we know that the running config is out of sync. So now I'm going to come back here and make another change, right? So this time I'm just going to remove this network to force that change to happen. So when I commit this change and go back to tower, go back to, so that's this. If I go back to tower here and look at the current jobs that are running, you'll see that a new workflow was kicked off. That's because of the Git integration. And now you will see that this particular job is going to fail. And the reason why the playbook is going to fail, and I'll show you the playbook real quick while this is running so it makes sense. So if you look at the playbook itself, it's fairly straightforward. The playbook simply pushes that BGP config onto the Arista devices. Now, if yeah, so you can see out here, right? So the playbook failed. The playbook failed, and you can click on the details to see why it failed. And over here, because the playbook is invoking caretaker, right? So here in this, oh, here you can see that the beginning of the playbook is invoking caretaker, and because caretaker is being invoked, it's going to catch this difference because it's doing a comparison of the two configurations, and it's going to print out the difference. So it's saying that, hey, interface loopback 25. So there is some sort of a difference on router 2, right? So there's something that's different in the running config versus the last known good config. So if you go back to our workflow here, you'll also notice that on failure, this workflow has two potential paths, right? So one path is it can sync from the source of truth to the devices, meaning from Git onto the devices, or it can sync from the devices onto the source of truth, right? So we can, but a human has to make that decision because, because there is this conflict. It's similar to like a Git conflict, in my opinion, right? And you'll also notice that this bell here shows that there are two notifications available for us. So these are the approval nodes in Tower, right? And these approval nodes can also send out alerts. So in Slack, you would have got this notification here saying that, hey, the deploy failed. So the first one was successful, but the second one failed, and this needs review, right? Somebody needs to go and review this. So you can click on this link, or you can just come out here and check the notifications here, right? So let's say I've decided that I want to sync from the source of truth to the devices. So I can simply approve this one, and I can deny this one. I can also configure these to timeout after a period of time if I like to, right? So I'm approving the fact that I need the configuration to be synced from the source of truth onto the devices. So now what's going to happen is it's going to push the configuration from Git onto the devices. And after that, it's going to try and redeploy the code, right? Now, when it tries to redeploy, Caretaker is going to allow it to happen simply because it will not detect any difference between the running configurations and the last known good configurations, right? Because we just synced up the device configurations with the last known good configs. And if you look over here on router 2, we should see that the interface that we had just configured, right, loopback 25, no longer exists because Caretaker has helped you clean out that out of band configuration. And now finally, the configuration gets pushed onto the device, and this deploy is happening. So let's wait for that to complete. And the change we should see from a BGP perspective is the network 27 should disappear. As you can see, the configuration has already been pushed here. So this must just be wrapping up. And you can see the Caretaker deploy was successfully complete now. And finally, this updated running config on all devices are going to be now backed up on the last known good config repository. So that's the demo. That's what I wanted to illustrate. And obviously, it'll work in this direction as well. So if you wanted to have updated the source of truth with the device configuration rather than source of truth to devices, right? You want devices to source of truth, you would have denied this approval and approved the other one, right? So, and now the whole change is complete. And if you go into the configuration here, you can see that network 27 has disappeared. Well, thanks for watching. Hopefully this illustrates all the concepts that I'm trying to point out in that blog post. I figured this blog post might require a demo to kind of visualize it better than just my normal blog post. So hopefully that was useful. Thanks for watching.